Hi, so last two videos here, we went over the theory and the design of how we're going to handle the EMP. I know it's a bit much for something so simple, but it's a good opportunity to learn and do more. And it's half the point of these videos is trying to learn something. The other half is I'm just screwing around on camera while making something cool. So we got some specifications, we did some weird doodles, we went through some logical designs and stuff like that of what I kind of picture for things. We didn't hit everything up on it, but we're not going to be able to in such a short period of time. So I want to get this done here before I have to go do other tasks, and so we're just going to get into it. So the first thing we need to do is I need to go copy the EMP out of ICBM and put it into our main core mod. And there's a lot of EMP effects we actually have planned, but these are the two we want. And the cool thing is of how I designed the explosive system is we pull these two and we just change a registry value, and nobody will notice a single difference on how everything is existing. That's the theory, at least. Practice, I'm going to have to probably fix something. So we're going to have to go down here into the core, and I need to fix things, so we're going to actually make a new framework here. So we're going to call this the Blast framework. And this goes into, yes, that's the right folder. So we want that folder. We'll call it the Blast. We're going to move a lot of the Blast code here, so when I start doing the restructure for 112 here, I'm going to restructure a lot of this stuff. Because we have a lot of Blast code sitting down here in the prefabs. We have code for Blast sitting down into the limping thing right down here, the World Runner Explosions. And I need to move them all. I need to put them in the framework because it is a framework. It is a framework for describing how we make explosions in the game. It's not a library. It's not something that gives you pre-built pieces and segments and systems for this. It is a functional component of the game. Therefore, it's a framework. At least that's how I've been told how frameworks work. So we want to fix all that. It's a big design problem. I kind of got into the idea that you put any pre-built components down here, and then I kind of forgot that it's pre-built components go down here, not just everything goes down here, because there's things down here that don't need to be down here. Like there's like the auto crafting system, that's a framework. The whole inventory system is a framework. It's not a prefab. Actually, some of this is prefabs. It needs cleaned up. That's the way we're going to put it. But that's not what we're here for. We want to move some code around, and we want to fix our EMP, and we want to get it going and fix a lot of the problems. There's a lot of problems that this will solve. So I just want to go like this, and I want to come down here. If IntelliJ will let me do this, by the way, because it freaks out sometimes when you try to refactor code. Go put it down here. Eclipse does the same thing, by the way, and I think Visual Studio doesn't even give you the option. So yeah, there was a handler here. So we're going to have to go look at that. So that's the explosive handler ICBM. And there's squat here, pretty much. Why is there even a special way to do this? What's the difference between this and an abstract explosion? I think it's only the implementation of the iBlast. So I don't see a difference here. So I'm actually going to deprecate this. And I'm then going to copy this, and I'm going to bring it down in here. So we're going to put down here, so this is going to be explosive handler. And actually I'm going to do EX handler is what we're going to call it. Abstract explosive handlers implements iBlast, and that's the reason why I can't find it. iBlast is an ICBM thing, that's why it's there. So iBlast, iBlast tile missile, what? Applied to blasts that are static and remain in place during a time duration. This needs to go in the core. IX handler tile missile, a version of explosive handler that spawns a missile tile on impact. That needs to go to the core, but needs to be called something else. And we have the iBlast handler. So these all need to go to the core and need to be renamed. So go take these and take the whole package actually, and go throw it in the API. So I'm going to have to do the version numbers on this. It's going to be a little dumb, but yeah. New package, last. And since we're kind of just screwing with things in the first place, okay, so what is this? Applied to blast that spawn an entity. So we have code for this. So is it in use? Apparently, we have stuff for that. Grenade entity. That's not even used, so I'm gonna delete that. Bye. Explosive holder. Explosive handle. Man, I need to clean this up so badly. So I want to copy a couple of these. I'm going to leave these two here because these are pretty specific to ICBM right now, and I'm going to recode them later. So I want to take this guy and I want to go put him in the API. Refractor, continue. I should have saw that coming. Yeah, okay, so Control-Z. Put that back where it belongs. So we can't move that guy, so we're going to ignore it. To be honest, I don't think it's even used. We're going to go down here and get rid of this part. I think this section is actually pre-implemented already here, at least it should be. So when you create a trigger, add data. Why is this stuff just not in blast? Like, all this stuff should be implemented in the abstract explosive handler, and it's not. All this stuff is just kind of non-existent. So what I'm going to do is I'm going to take all this crap, and I'm actually going to go put it up here. Because I believe this stuff should be in here, and it's not. It might be half the reason, though, is because this is kind of... I think a lot of this stuff actually does interpret things a little differently. There's like a multiplier scale system going on here and a few other parts. So we want to make this extend abstract explosive handler. And I need to get rid of that, whatever that is. I kind of do want to implement this stuff, but that's not there. Okay, so this is good. We do have a super problem here where it's not implemented properly. Let's be protected. This whole piece here, put this over here. So we protect a final multiplier, and what we'll do is we'll go ahead and make a version where it's int multiply. We'll go this dot multiply equals multiply, and then we'll do a normal version of this, which was already there, that goes straight back down to the method we just created, and we'll do a 1 by default. That way it works. Okay, so this is like a scalar factor is what multiply is. And that will get us our system here. So this basically is deprecated. Super multiplier. Because there's nothing in here now, so this has all been transferred to the core. Shows there's an error in here, but I don't see it, so I'm going to assume there's none. Abstract explosion says there's errors, so blast.set location. Can you not? Yeah, I don't think you can set the location of a blast. So we need to change this to this. And then get yield modifier. Go remove that part, so that way it's there. And actually, let's go ahead and move this down here, so it's cleaned up a little bit. That's an override. Actually, is this even part of the API? It actually is. So make sure that's actually specified that way. Add data, blast, and all looks good. So that should transfer rather well. There's going to be some errors, so let's go ahead and hit build and build project because it's going to error out a few times. Okay, so let's pop that on the other window and let's see what it's complaining about. What? Okay. Why? Okay, so what's this saying is that add info to item clashes with basically it's super method, which doesn't make any sense whatsoever because I think they're the same method. I'm going to hit rebuild project from scratch because I think there's a problem with the compile. This is where I also said earlier in one of the episodes we recorded earlier than this, is that there's something wrong with IntelliJ. And I probably should have restarted this in between episodes, but I didn't. So we're kind of just stuck with it being its derpy self. Okay. Take a little bit for this to compile. I guess I can go dig around here. That's actually the prefab that's freaking out. It's doing the same thing. I don't get why it's complaining. I particularly don't get why it's complaining because these are like the same thing, practically. And I didn't change the add information method, so I didn't touch it. It's practically the same. But it's going, okay, this method clashes with this method. But yeah, it's really weird because you go look at this. It's going, this method clashes. Add information, player, item stack, list of string of type explosive handle generic has the shirt add information player. Why does it think it's a list? It does not override it. It does. There's an override there. There's something wrong. I blame generics. I really do. I think I have to like go like this is blast. That's what this is. I fixed it. I hate generics so much. They're supposed to default to that by default, but they don't. And I guarantee like everything else that's broken is broken because of stupidity. Yep, this broke for the same reason. Something broke with this. I'm going to hit build rebuild in here in a second again. So build rebuild project because it's oh, that's why. I see why this broke. All this needs to go away. This needs to be multiply. And close a few of these real quick. And I think I need to go down here and just delete you. I don't think you're even needed. Because blast EX can just, or EX handle can extend that. Yeah, it's still having the same problem. What? Oh, it's because I'm not passing B. down to this list. This is what I don't get about generics sometimes, is they do this. They do this behavior. It's part of the JVM that's causing the problem. But for some reason, when you don't handle generics correctly, you can lose your generics on other objects. And I've no clue to understand why it's happening. Because it'll go like, hey, you're not extending this method that's in your super that has a generic on it. It's going, hey, you lost your generic. It's like it's stripping generics off of every method, and it's confusing, to put it the simple way. Speaking of stripping things, by the way, we're going to add a, probably here in a couple episodes, we're going to do a strippable system, very similar to how COFH and reworked do, in order to fix the IC2 support, for those who actually keep wanting the IC2 support implemented. That's the plan of how I'm going to fix it. So basically how it'll work is we'll implement IC2 code onto our objects, and then we'll go and use a special way of ASM to remove the code if IC2 is not present. That's the only way I can think about how to do it. The alternative is to come up with some weird structuring, and I'm trying to avoid the weird structuring. I'm not against it though, but actually I have a better idea. I'll test the idea later. I'll do a plan similar to what we just did in the last episode, and then we'll implement it. So yeah, that fixed it. So we got it moved. Yeah, let's go ahead, and we want these two guys. So how the current system works is it does a whole bunch of fun stuff. It sets off an EMP, some spark and stuff. We'll have to move the audio effects. We need to move registry entries. So right now, ICBM registers EMP. And actually, you know what? We're going to leave the ICBM EMP registered as is. Or actually, you know what? I can make a conversion system here. Actually, you know what? I don't need to make a conversion. Because the ID I don't think is prefixed with the mod ID. I don't think it is, at least. Register explosive. ID, yeah, enable ID is registered. EX contains, yeah. So we store it by ID, so I don't need to re-register it. So I'm going to go ahead and which one to use EMP? Right there you are. Comment it out so you remember it was there. Then we're going to take the whole line here. Then we're going to go to Volts Engine here. Go find the core. And we need to go server proxy. We want to register this in the init stage. And then we're going to need to register a different version of it, because I think there is a separate version. So this would be Volts Engine. Actually, I think it's just called Engine. I keep forgetting I did rename this like years ago, and I always forget. Speed domain. Is it? References. There we go. And of course, the EXEP. Keep the name the same. The names are all lowercase now, so I think I actually might have broke some people's saves, but I hope it didn't. I think I fixed it correctly. So, register explosives. This will be handle commands. So there is a separate version for EMP, I believe, for the client side, and this will be in ICBM's client here. Nope, there's not. So this actually needs to just be common registered. Yeah, there's no real graphics for the EMPs right now. I might add some later. Actually, we'll recode it here in a second. So I'm going to leave that there. And then we need to go find the client proxy and put a different version in there. So I think there still is some client-side behavior for this. Client proxy. Of course, this needs to be in the init phase as well. So register graphics. There's a lot of graphics here. Register tile renders. Register graphics handlers. Register client-side version of blasts. So what we would have is we have like an ECEX on this side is what it would be. A little different version, but right now we're going to register the same guy twice because there's no separation right now between how the client side and server side version work, which they're supposed to be. Because what this, like audio and stuff, actually audio needs to be triggered server side. It's this display code that has to be triggered client side or it'll break. We're going to leave all that stuff alone. We need to leave our power drain code alone. I need to abstract it real quick so it's a little cleaner. And we're using simple Pathfinder, so we have to program our own Pathfinder. Right now how this works is it just goes from tile to tile and does its thing, drains the tile power. We don't want to just drain the tile power. We want to have an effect on the tile. Do some logic. So this is why we need to actually make some things. I need to build a placeholder here. Make a file, call it placeholder, of course. Creativity is not my strong point, but we want to do EMP. I'm going to probably move the TNT explosion over here as well. I'll put this code in here. And what I want to do is I want to get this code out of here. So we want to do our effect. Actually, I think I can I do this? Actually, that worked. EMP drain edit. Of course, this is a version of a block edit. We have to do all our imports now. We have to clean up our code, fix all the bugs and problems, and everything we've just broke in the last 5 minutes has to be changed. Chunk is loaded, encapsulation. I don't think that's the right check. Yeah, that's not the right check. This could explain why I'm having weird problems with the chunks. There is actually a check for this now. There we go. Because I believe this actually does run it. Yes, that does the proper check right there. So that will fix any orphan chunk loading. Do place, there's a lot of things we're going to do. So right now this just clears energy, so we got that separated out, which will clean up the code a little bit. So now we have all our stuff here. We're going to do the graphics version of this, so I need to make a different version. So we Java class blast EMP client extends blast EMP. And this will be just to get all this crap out of here, so we're not having to stare at it while we're trying to work. So all the graphics that go there. I mean, you guys are looking at this like, oh, there's no actual graphics there. Well, yeah, there's not. We'll implement them later. I'm not sure what we're going to implement, though, but later it'll happen. I'm positive on that one. Fix the audio here. Let's actually make a thing up here. So this will be public static final. And we're going to do start audio. So this will be, actually, I forgot to put string in front of this. So that way I can take this out and we can do start audio. So I can change this later without having to look through the code of where this crap is. This will be edit audio, and it'll be end audio. And of course I'll go through each one of these and change it. So end audio is EMP. And of course we'll have the spark, which is our edit audio, so this will be edit audio. Actually sounds pretty good. I actually haven't heard this one or this one actually go off, but this one does go off. You can hear this one. I think it's like a range check on setting things off. So we need to forego a lot of things. That's a good way to put it. So we need to not extend simple path. Instead, we want to extend just blast, because we're not going to have a conventional pathfinder anymore. Which means this method is no longer usable. And I have a dog that was I swear I can't make a single video without this dog just going like, hello, wants attention. Come on, Tess, can you lay down? She recognizes I have food and wants the food, unfortunately. So let's see. Add post trigger on world unload. So there's a method in here that we need. So we have GetAffected Blocks is what we actually want to call. And this is what normally triggers pathfinding. We have no pathfinding, so we have to make our own pathfinding now. And how I want this to work is I want to grab all tiles. I have a system for this, although it's not designed to work on modded tiles yet. I'll fix that later. That's not important. There's more higher priorities right now. I have a way to fix this actually. I'm trying to think. There's stupider ways to do this. I'll think this through later. Right now we just want to keep it simple. So Tilemap, I believe is what it's called. Dot get radar map for world. And we actually want to make sure that we check to see if the radar map exists. This does piggyback the radar system. I made this. There's a video that actually shows me making this, where I was like, I need a way to track tiles, but I don't need something specialized to this. I just want to know what's going on. So you go map.get. You want to get like radar objects basically, and we want a range. This is where I talk about that there is actually a radius check. So actually I can do the distance check, which still does a cube. But that's a lot easier to do than what I'm thinking about it. So we have X, Z, and then we want our distance, which is size. So this will give us a list of radar objects. And actually, so this is, I'll change this real quick. So this will be edits. Tiles is what this technically is. Actually, we're going to change this to objects because we don't know what's in that list. We can assume it's what it is, but the reality of it is somebody could put junk in my list and break my system, and I would be powerless to stop that. So I'm going to go, okay, if object is instance of radar tile, then we're going to go, okay, tile entity tile equals object dot get. I guess it's just tile. Do I not have a getter for this? Oh, you were poorly implemented. Need to be fixed. So totally need to be fixed. We can fix it on this side without messing with it. So tile.isValid. Just make sure you do an isValid check in case the tile was invalidated. Or actually, rather, isn't invalid. You guys get the point. Then we want to do a distance check. So we're going to go, okay, and in a new pause tile. Do pile dot distance. This, I think you can distance this, is less than size. Yeah, I will just do less size. Technically, this is a to-do center. This is not a perfect check. It's going to be off by 1 meter in some corner. Actually, I could fix that. Just do it this way. Waste of math, in my opinion, but it works. So that gets our distance checks. Now we know, okay, this tile is valid. It's within distance. Now our next check actually should probably be our first check. Is go, okay, if tile is instance of I, EMP, actually, that's all. That's not what I want. I want IMP EM interference. So we want to make sure it's that. That's about it. I don't really care to do anything else. The other option would be, or we go universal energy system dot is handler. And we want to just pass in the tile, and we want to pass in null because we don't care what side it is. Direction does equal null. Do is handler direction. Module is handler. Okay, yep, that works. Okay, so that would go. We would know what it actually is, essentially. And then running this check, we don't care if it's an is-valid check. Actually, we probably want to still do the is-valid check and then put it up here, put this here, but we don't have to run the distance check. Distance checks are somewhat expensive, so then we can run that afterwards. That'll work. Theoretically, we can actually do this. Yeah, it's not as clean of a solution, but it works. So now that we know what our tile is good, now we want to go, okay, if EMP interface, or instance of, so we go tile instance of that, we do our action. So tile dot on electromagnetic, we pass in our distance, which means we want to technically, that means I actually do want to pull this back down where it was at. This is where planning did not go as far as it probably needed. So we'll do this, and then input that way, and we'll go, okay, if distance is less than size. That's probably not what our actual distance check is going to end up being, but you would get the point. Actually, we can make a method down here for this. Public double range. I'm going to get EMP range. And that way I can modify the range separately and do special modifiers. Like if we're in the end, I can increase the distance if I really cared. There's like special handling I can do there. So we want to pass in the distance and then pass in this guy. This guy, of course, needs to apply. Actually, what is our. We want a strength value. This is where we're going to have to actually do our check. So we want to go, okay, float strength. Technically is how I'm going to do that. Technically I'm going to do this. This is a better way. Public void do EMP. EMP interface interference. So we get tile. And then of course you want to do double distance. And then that way we can go down here. Put this down here. Then I can do tile. Call that. And the reason I'm doing this is to separate the code. It's always a good idea to do that if you start to get the code starts to get a little complicated, because it'll clean itself up that way. And then if we're not the system there, we want to go, okay, if we are a handler, so we go if universal energy system is handler, and actually this will be an else statement, because if we do have this interface, we may not want to drain energy from this. So this will be tile null. Then we want to go to do drain power. And actually, what was the previous call for this? Do we still have the change block? Yes, we do. So it's handler, then we just want to do this. We want to add, so I'm going to go edits.add that. And there's a location for that. So this would be tile action. What is this? Tile and percent to drain. So we technically still need to figure out our distance and stuff. So we still need to pathfind the object and figure out what our power is per tile. But we're going to do something like this. Public void drain energy. This down here, and then that's what we want to do, by the way, is actually return our block edit. So this will be iBlock edit, I believe. Well, actually, what does it want? So I want an iWorld edit object. So iWorld edit object, iWorld edit object. So then we add. Actually, we want to make sure we get the edit, so we're going to go iWorld edit equals drain energy. This would be tile and distance. And we go, okay, if edit does not equal null, because we could change the logic here later and decide that we want to actually have it be null. And I can recycle this code, so I'm going to go down here, put this down here, put this up here. And then do this. This lets us put more logic behavior in here later if we wanted to. There's our two methods. Now we need to pathfind to each object. And what we kind of messed up here is there is actually a separate system we can do. So I need to do list tile entity tiles equals new array list. Actually, I have a better idea. New cube. It's linked list, and this will be a cube. Okay, so here are tiles. I kind of forgot that I actually need to move some information here. We want to collect our tiles first, according to our design we made in the last video, and then we want to iterate over them. This reason we're doing this is we actually want to use a while loop here. And then we're going to go while tiles is empty, so while it's not empty actually is what we're looking for. Then we're going to go, okay, tile entity tile equals tiles.pull, which gets our next tile. And that way we can loop through this. And what I can do when I loop through this is if I ray trace across another tile, then I can go ahead and remove it from the list if I hit it. So there's a system there. So this will be find all valid tiles, loop valid tiles. Then we're going to want to do a ray trace action at some point here. And make another method here. So protected world edit handle. And this will be tile entity tile double distance. The reason I need to do a handler method is because I need to gut this method real quick. And I need to put this down here. Actually, do this. Put that here. Go ahead and handle that. And then we want to actually put this part here. And Taz, come on, quit. Fortunately, the dog wants attention again. It's one of the downsides of having pets. Although I love the dogs, so. So this will be edit equals handle. That's what this will be. So passing the tile, passing the distance. Hey, come on, calm down. You were let outside earlier. You were just fed here half an hour ago. So calm down. Here, pet. Ah. Okay, so when we return this, return that. Anything else we return null. That gives us our handle method. And then that means in here we can figure out our ray trace behavior. So we want to ray trace from point A to point B and figure out what is between us and the next object. This is the hard part about this, where I didn't really plan this part through. Actually, want to get rid of the strength here. Return this. Actually, tile unapplied. Actually, we can't run applied on this. We got to run something similar to this junk method here. What does this guy want anyways? This wants a double, but we're giving it a float. Oh no, what's a float, but we're giving it a double? Why do you want a float for? Oh, percent to drain. Yeah, we need to figure out the power here. So we want to go double power, and then we just want to pop power right there. And then we want to change this to actually accept a double. So final float double. Change this to power. Change parameter to power. Factor, and then we come down here and what we want to do, clear energy true. Oh, we don't even care about what power is in. We're just killing the energy, period. So there's a lot of implementation here that's still not done, okay, according to that. So still need a power check. So we need to calculate how much power we're going to be doing. I also need to sort that list of linked list there. So I need to do collections dot sort tiles, and then we went new comparator. I think it's distance comparator. I'm going to take a pause here to go see what my dog wants, and I will be back. Okay, so we're back here. So yeah, my dog just wanted to be let outside to bark at the neighbor for like 2 seconds to back in. Yeah, that's dogs for you. So I can't remember what this is called, but I know I have a comparator for this. So I know there's one in here. Unfortunately, the system is being strange, and I can't find it, and I think it's in the API. It's like implementation, transformations, sorting, vector 3D, comparator. And we want to compare it to this location, and I think we want to false. You're a comparator. Why can't you be applied? iPause 3D, but you're trying to sort iWorld edits, which should be iPause 3Ds, which, no wait, it's Thailand. Oh. I could fix this. Not ideal. So this would be tile locations. And then we go here and we go tile locations dot add new pause tile. I probably could actually make a sorter for this real quick. You know what? No, wait, we'll do it this way. You know what? I'm going to do it this way because I don't want to make a whole bunch of new code for this. It's a little wasteful. I'll come back here and do it another time. And why won't you sort? Because you're a queue. If I pass in a linked list, it won't accept it. Just being absolutely dumb about that. So that means we want to switch this to tile locations. Then we're going to actually have to do iPause 3D pause equals tile locations dot pull. Then we want to go. Or we actually don't want to go world, we go pause.get. Oh, sorry, I haven't implemented that support yet. What do you, yeah, you're part of the vector system, so I can't do that on you. Okay. I could if I store this as an actual pause. There we go. And then I can then change this to a pause. That way we can recycle some code here, and I don't have to go make a new code for this. And I can call get tile and do world. And then all I have to do is go, okay, if tile does not equal null, and then I also have to do a isValid check again because, no, actually the tile should not be able to invalidate itself in the amount of time this is running. Or, no, we're threaded. It can invalidate itself. Make sure it's not invalidated. Okay, so we get our stuff, we sort it, so we sort based distance far. The reason why we're doing a largest first check is we're trying to pathfind from our center to the outside tile. So that way every tile we hit between it will be hit first. So if I hit a machine and I lose 50% of my power on it, I lost 50% power. If we go the other direction, then I have to store a whole bunch of data about what tiles I've mapped and which ones I haven't, which then leads to a lot more data necessarily being used, a lot more CPU being used. And it's easier to go from furthest to then the closest because then you'll hit the closest first and remove them from the list. So we want to path our tiles. And then figure out something here. We're going to have to pass in the list of tiles. And this is where a problem presents itself. Linked lists are not very good for being searched, but we're going to have to do it anyways. So we're going to do tile locations. This location is going to be removed from there, so we don't have to worry about that. And then we got an out path. And I can't think of the best way to path tiles. Like if we were going a straight line, all I have to do is go +1, +2, +3, +4, but we're not going to necessarily always be in a straight line. So I have to get every tile on that line, and I'm not sure how to do this. I guess the easiest way tricky this is. We need a raycasting system. That's literally what we need. So world dot, because if you do world dot ray trace blocks, this is what we're trying to do, and we need this whatever this monstrosity is what we're looking for, and I'm trying to think of the best way to do this. So I need to more or less clone the ray trace method, which I have to get back to it again because I scrolled and it disappeared. So there's this version. This version, of course, is going to call this function. It's this whole function, which is the ray trace. So we're going to want to copy this and make our own version. So go ahead and copy that. And we're going to want to put it at the bottom. That way it's out of the way. So be world.getMetadata, world.getsBlock. We're just going to flat out want to ignore certain blocks. So this is one of the things we're going to have to do with this. Make sure we do this as well. Wow, there's a lot of junk in here. So ray trace blocks is what we're going to call it. And then this will be start, end. What do these methods do? Where are you used? Can collide check. Get collision box from pull and can collision check. So this uses the collision box is what this uses. So I don't really care about this because this is trying to see if we can ray trace from the starting point. Of course, we're going to be able to ray trace from the starting point, so I don't need this. Which means I don't need this. What did I just delete? I deleted K1, which is being used for whatever it's being used for. Recycling a code. Not much of a fan of it. So while K1 is greater than equal to 0, start is not null. I don't care. Well, I guess I do care. Why is that checked every single tick? I have a feeling like the start is. Let me do this real quick. I'm pretty sure you can't change a vec3. Actually, you can. So that's a new one. So we don't want to have it changed, but of course, if they're going to let it be changed, we're going to have to look through this. So we got a lot of checks here. So if I is greater than L. So if I equals, or L equals I, then we return something, something, something. Yeah, there's a lot of things in here that I'm not quite sure what's going on. Reverse engineering code in real time. Probably gonna make this video length much longer than it needs to be. What I need is some really nice math, because what we can do is recycle the ray trace system. I just have to necessitate getting the correct forward cast or something like that. Create vector helper, double, vec3. So I'm not going to mess with any of this code because I'm going to have to spend more time reverse engineering it. But it's this code at the bottom here is what actually does all the work. So this is where the collision checks were actually done. So what we want to do is we want to figure out if our collision box ray traces something. There's also this block collision ray trace. Shoot, there's more code. Is vec inside? Okay, I'm going to leave that one alone. So we're going to be using collision boxes, which is not ideal. Or do we need to use collision boxes? So I just want to know if there's a solid block. So what we want to do is we want to go, okay, so we make a method down here. So we go protected boolean can pass through. We're just going to do block. We'll do meta too. Int meta. So we go if can pass through. We want block 1, and so this needs to be changed. So this needs to be changed to block and block meta, so I can actually read the thing. Block meta. So we want to make this a not symbol because we only care about blocks that we can't pass through. We want to know like what blocks did we do things on. So we get this. So we want to return block is solid, which means we need a world location. So world int x int y z, of course a block at metadata. Okay, and then of course we want to pass in world x, y, z. What else did you want method-wise? Of course you want the side hit. Isn't there like a normal check for this? What I want is I want to know if it is a full cube pretty much. I guess there's a different check I can run for this. Can you quit, you stupid piece of software? There it goes. Like I'm trying to click the method thing. It's like, here, I'm going to show you like what you can do. Is opaque cube. So if it's not an opaque cube, which means it's transparent, which means you can pass through it, basically. And then what we'll do is we'll have some kind of registry. So go to do list of blocks we don't care about, grass, glass, trees, water, etc. We don't care about a lot of that, so we need to put the world here, and then this is the data it's using for its position right now. Is it using the starting position as the coordinates? IJK L1 something. It's not, it's using weird numbers. So XX YY, and we'll see where these are positioned at. So these are being initialized up here. So that's what I thought. They're using the starting position. So this is our start position. This is our end position. That's good. We got that figured out. So we got our block. We go, okay, if we can't pass through it, so then that's when we run our check. So any block we want to ignore, just ignore it. I don't care about any of these booleans at the top, so let's get rid of all these guys, and I'm going to just fix whatever codes with them. If XX equals I, return null. So if our start equals our end, or actually it's current equals end, return null. Because that means we haven't found anything. Okay, so we assume our block is solid. We have to get collision boxes though, so like we have no avoidance to the collision box thing. So we want to go, okay, is there a collision box at the location I'm currently at? No collision box, no collidable blocks. We don't care, no collidable blocks. So we get rid of that. On collision check, what is that? I don't know what that is. Boolean, whether the player right-click holding a boat. So this is going to be false. We actually don't care if we can collide with it as much as we just want to know what's at the location. Actually, if this is doing the whole location thing, then we should at all times know what block we're standing on. Is this running some funky math that's figured out what the flip we're doing? Actually, how is it doing this? It's got an ideal. I just don't know how it's got the ideal. So where I gotta read. Oh wait, we're doing some normalization here. Here's some deltas. Delta distance. Normalization. Some values. Tech 32s. There's some code going around here that I don't actually know what it's doing. Anyways, check block. So this is the part we want to do. We want to just check to see what's going on. So it's, why do we have so many returns? Just get rid of that guy, get rid of that guy, put this down at the bottom. And what is our while loop condition? So apparently we can only loop 200 times, so there is a limit on the distance of a ray trace. I'd never do that. I guess it makes sense. We don't want to loop too many times. So we don't actually care about moving object positions with this. We only care about collecting information about our tiles. So we want to make another system here. So protected void on pass through tile. And we just want to call this every time we hit something. So we know what block we are, so I'm going to put world int x, int y, and z. Get rid of all this junk. On pass through tile, world x, y, z. I actually want double x, double y, double z. So that does our on pass through. So this is called every time we pass through a tile. And what we want to do is we want to go, okay, if can pass through tile. So we want to go, okay, if we can't go through this tile, then we want to do something. And then this is, of course, now that we no longer have, I guess we want to still do the blocking. So block equals world dot get block x, y, z. And then int meta equals world dot, in case we want to do some weird things like shoot lightning off of any block we pass through. So there'll be our special handling down here, and that'll be do whatever. It's block meta. So we go, okay, we can't pass through that. So now we want to do an action. So this is where we actually figure out what it is we're doing. So we know we want to have so much energy left. So we actually want to have a value off here. So we're going to go double is our return. So we just want to return our power value. So we're going to have double power. And just return power. So if we ray trace to our target without hitting our target, then we're good. Just return power. So we're going to go, okay, power minus equals that. And every time we pass through this, we want to modify the power value. This actually needs to be double. I could make an object for power, but I'm not gonna. Double power. We return power. Pass power in. ahead and do that. Don't need to store you anymore. We'll change the name of this. I'm going to call this end X. Start keeping track of my locations. And Y. And C. If we're going to do it this way too, what we can also do is switch these to iPods 3D. So I can change this code here later. I'm going to have to like clean some stuff up though real quick. So what I want to do is copy, or not copy, I want to select this area. And I want to go Control R, X chord, replaced with XI, Y chord, replaced with YI, Z chord, replaced with ZI. There we go. So that way it's using my code, and it's not so much Minecraft anymore. It's now starting to behave a lot more like my code logic. Yeah, we're good here. So be limit. So that's pretty much, this is a for loop. It doesn't look like it, but this is a for loop. I'm guessing there's a way to control that limit a little bit better. Still don't know what all the flags do. The positioning data, I mean, I think these are position data. There's a lot of really weird stuff. I'll have to slowly work my way through here, and I'll figure out what everything does eventually. And here's that spot where I was trying to figure out where were we modifying things. That's where you're modifying things. Track 32. I don't think we need VEC 32. I think we can just do like, I'm going to Control Z this though, because it is messing with the start position here, and I can convert these to VEX rather than screwing with the whole process. Well, the first thing we want to do is just get it working, then we can clean the code up later. So we got passing through, we know what we're doing, so now we know we can do things. So we go tile entity, tile equals world.getTileEntity x.y.z, and of course we're going to go okay tile.isValid, or is not invalid, and we want to do things. So we're going to go okay if tile instance of I energy interface. This is also where we need to be passing in that list of things. Don't need this anymore. We're getting there eventually. Does this thing still want to float? So I didn't change that. Okay, this wants to know what power we have left. So this will be double power equals ray trace blocks. And our starting point is going to be the center of the thing. So this will be 2pos.2vec. And then our endpoint is going to be vec3.createVector tile.x coordinate, tile.y coordinate, tile.z coordinate. It's a little bit quicker than me turning it into a pos and then turning it back into something else. And we want to trace to the center. I'm going to pass it power here. So we have a starting power value. Right now, this is pretty much going to be distance. Actually, no, we'll make some value here. So go protected, double, if I can type, get power, and then we'll go double distance. So there will be a power value based on distance. And right now, we're going to return distance times 100. So we'll go get power, distance, and the last thing we need to pass into this is actually the tile location list. So we can remove tiles so we're not double pathing. Add linked list of fourth requirement, And then now we can put power in here. So power there. And of course we want to put power on this one as well, even though we haven't done that yet. Add parameter to method. Second method, third. Okay. There we go. I wanted to read over that real carefully, make sure I didn't mess it up. So we have that on there, and what we want to do is we want to go okay. We want to make a pause out of this, so I'm going to go okay, pause equals new pause xx yyzz. And cool thing is we can actually put pause right here. I'm actually going to start pausing these. That way it's a little easier to do some of the stuff. This will be pause.getBlockWorld. And when we switch over to the new version of Minecraft, this will make life a little easier too, because the Minecraft switched over to its own version of what I'm using. They have what's called a block pause that replaces all X, Y, and Z calls anywhere in the system. That way I can do this. Pause. Oh, why did that? Hand was not even on the mouse when I did that. I just decided, like, oh, we're gonna select that whole section. But what I'm gonna do is I'm gonna go okay if tile locations dot contains pause. Tile locations dot remove pause. This is a little bit of an expensive operation. This is like an O of 2 operation or something like that. Basically, they go in. It's actually 2n. So expensive, not like severely, but it's. I need to make a better way to do this later. Make sure that's a final. But that removes it, so we don't path it twice. But we know how much power has gone through. We can handle it. And then what we do with this is we go okay, handle, and we pass in tile, pause. Oh, we don't want to pass in tile. Where is it? Wait, what's if we scroll all the way back up, distance, and then tile location. We'll have to calculate the distance, so we'll have to go pause.distance this, and then power. And how does this work? It returns a world edit. It's not what I want. I do need to actually do it though. You know what? Instead of... No, we do want to put the world edit here, but we need to go copy this method. But then the handler doesn't do the edit. So that means I have to pass edits down into this now. Complicated this is getting. So technically that means this actually needs to be a void. And this needs to have this at the end of it. And then what we want to do is pretty much move this system back to where it was. I know we just changed this a few minutes ago, but yeah. Do this, grab that, put that there. And we want to go edit equals, and then we can add everything, except we want this to be null now, so we don't want to call ourselves. And we go all the way down here, and we can call handle, and fortunately we need to put more data on this. So what do I need to have on here? I have to have tile locations on the handle, I have to have this. So there's a lot of data we're going to have to pass around to make this function. So make sure we have tile locations, edits. This makes this a recursive function, by the way, so it's actually not ideal. I'm probably going to have to replace this with an iterative function later, which is going to suck. For those who don't know what the difference is, recursive, you're calling methods repeatedly to do the same task, which means you're recursing in yourself. You're going into the same container repeatedly. Think of like box inside of boxes. Where iterative is like stacking boxes. And iterative's better, is a way to put it. It's not as demanding on systems. Okay, so tile locations. What am I missing? There's no power passive for handle? Because we recalculate the power. Why are you complaining? Because you need edits now, don't you? So we got to pass power back in here because there's a starting power. So I'm going to go double power. And that means ray trace blocks needs power. And right now we were passing power in this spot. And how we want this to work is that we have to pass in power up here. A lot of code of bouncing around. Most of you are probably have gotten lost at this point. I do not blame you because I'm pretty lost myself. Tile locations and edits. I think I got everything set up though. So how this flows is we're going to loop through everything. Every tile we find that it doesn't get removed from the list is going to have handle called on it. It's going to start with this power as it ray traces out. Every block it hits is going to lose power. So that's we're resetting the power value here. And then it's going to apply the remaining power as long as the power is above. So if power is greater than 1 actually. So if we hit 1, we're dead. There's no power. And it's going to do something. So 1's our cutoff point. This way we can't infinitely loop, by the way, so there's a cutoff point of this. And then it should work. Now the only thing we gotta do is we gotta make an edit system. Which, hold on. Yeah, we gotta do this. So you gotta make a version of drain edit, so this will be, we need something similar to drain edit. So this will be EMP something edit. So we got EMP drain edit, which means it's an energy drain edit. Actually, we're just going to call this one EMP edit. And we're just going to use this right now, and then I'll recode it here in a second. So return new EMP edit, new location tile. The reason we store locations, by the way, instead of the tile itself is because it could change. And this needs to be cast a tile. There we go. And that should work. So that's functional. The only thing I could see probably going wrong is this whole ray trace system doesn't work, which means we'll have to debug it quite a bit. But we now have a system that should do its job, theoretically. And I need to debug code. So system.out. That wasn't right. System.out.println EMP tile. Tile. There we go. So that way we get some debug information. And then we need to make sure we also do like distance. So we have information in the console. So we know what's going on. No guesswork involved. Okay, and I think that's it. Audio effects need to be fixed still, but I'll do that myself because we're at, I want to say, an hour in this video. I mean, there's 2 halves to this video, so it's really hard to figure out where I'm precisely at in the hierarchy of needing to probably do things. Wait for this to load up, and we can see how badly we failed. I'm hoping we did though, because I love if the new EMP works the way it does. This is only going to work on tiles from VE until I fix the tile map system. So how the tile map system needs to behave is that it goes through the tile list on the server and just puts them on the map and goes, okay, this tile is here, 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 and just it works. A lot of other things I need to do with that too. The whole reason I'm doing a tile map system is not just because I can access the tiles. Eventually, I'm gonna start cataloging like a heat map type system. So it goes, okay, you've had like 20 tiles here, and they're running like this kind of performance. They're doing this kind of interaction. That way, you can open up a mapping game and go, this spot is really laggy. This spot is not laggy. This spot is producing all my items. This spot is doing squat. That's one of the plans. I mean, there's tons of plans involved in this. basically building up an engine is what I'm doing here. That's the reason it's called Volt Engine after all, not like Volts Core or Volts Lib or something like that. It is a content development engine. So far, so good. Although we shouldn't be crashing and loading in the game. Okay. Now what we should see, because I didn't do any other work yet, is that when I fire an EMP, we should see that these guys have been EMP'd in the console. So, some packet failures. I heard lightning go off, which tells me that something was EMP'd. Or why we hear the taser go off is basically what just happened. Okay, so debug time. Okay, so we have a radar map. That's cool. It has 11 objects in it, so if we actually open up the object list, we have radar tiles in here. So there is a battery, power generator, sentry gun, a wall tile. That's the thing with the tile system, is there's going to be a lot of junk in it. That's the reason why we're filtering it. So, yep, radar tower, yep, tile added. So we know we got tiles. So now let's check the sorting behavior. Not going to really get much out of the sorting, are we? I can open up the sorting list and we can actually take a look at it. It sort of looks like it's sorted. These look like the farthest tiles away up at the top. It's hard to tell because I don't know where the center point is exactly, so that's done. You know, actually should be right here. Objects. Actually, no, let's not do that because I need to keep using the debug information. So we go down here. Cool. Finds a location, finds a tile. Cool. Distance to the tile is 1. That's good. It's in our range. That's good. We got our power. Okay, we're starting to ray trace blocks. Power is 0. Interesting. Put a line here. Actually, I want to put a line here. Okay, so how much power? We start with 391 power. Power is passed in, so let's go into our ray trace method after we finish doing the whole 2-pos thing. It's going to do that again here in a second. There we go. It's going to do it again. I don't like IntelliJ when it does it sometimes. Okay, so we are definitely a number. That's what this means, by the way, not a number. It's a check because you can sometimes with precision get things that are not numbers. It's weird to think about. It's going through here. It's being a little finicky though, because if checks and stuff. Debugging is not the smoothest thing on a CPU because this whole section can spit through the CPU in like a nanosecond. So it's literally sending like single line operations to the CPU at a time and then figuring out what it's doing and then sending another instruction. CPUs do not like that. That's not what they're for. Although they make special CPUs just for debugging, if I remember correctly. It's been a while though. I mean, we're getting a little bit of understanding of how the logic's behaving. Not a lot though, because I still gotta kind of reverse engineer this code and figure out what the flip is going on. So much. You know what? I should put a break line all the way down here, and that would be better. So we got our position. Did our tile, did we contain that position? Nope. Okay. Now we want to minus equal. Oh, I found our problem. That is our problem. There we go. So we got an EMP drain on the sentry base. And then that was it. So it just ran... Then again, this is a small EMP. Let's get a bigger one. I think it only had like a 2 radius on it. There we go. I'm going to like leave this off because I... Oh, are we going to crash? Oh, by exception. Yep, we forgot to do this. That's not even well. So this is where I was talking about, you know how you can get that position and you could pass it in and there's nothing, well, that's because there probably was nothing there. Oh well, 1 step forward, 3 steps back. Surprisingly didn't crash the game because I love how my code is designed. It's designed to catch errors like this. Okay, so let's go look at the code. And we just fired that off. And there we go, look at all that. So we just killed a whole bunch of batteries, killed a sentry gun. It's working. It's doing what it's supposed to do. The only thing I can think of now is to make sure the power is draining properly and everything else. But I'm going to go ahead and end this video because I have this cheeseburger, which is now turned to ice next to me because my brother brought it to me like 50 minutes ago and I didn't eat it. And I'm going to go eat that. And I'll be back here later, either tomorrow or next week with more of this stuff. But we got the EMP kind of updated. It's now a little bit cleanerly implemented. The only thing it needs left is we have to do like power drain properly. I have to implement the actual EMP itself, so like the actual method calls. I have to then implement proper support for IC2 and RF and fix Ender IO support, and then go test it on a ton of mods to make sure it EMPs properly. What I can say though, with a lot of RF mods, there are going to be problems because I've asked King Lemming about this a couple times, and he told me no. Called me stupid on one occasion, but told me no. I'm going to ignore the stupid part because he's more probably frustrated with me rather than actually calling me that. But I asked for a way to set power to get rid of power out of tiles. There's no way in RF API to do this. You can drain power out of a tile, but if a tile refuses to drain, you can then not do anything. So there's 2 solutions to this. The current solution I do have is that there's a system that keeps continuously draining power out of a tile until it's empty. And the other solution is I directly edit tiles. I've done this for thermal expansion. It's the reason why the thermal expansion one does work, but then if you go to Draconic Evolution or something else, it does not work. So this will be fixed over time, and eventually I'll get it nailed down, and I will find a generic solution that works. But it's going to be a while. So I'll be back here later. See ya.